All right, everybody, this is 1.1 Nets and Drawing for Visualizing Geometry. Okay, we've finished our algebra review portion of the course, and we're going to move on to our geometric thinking. All right, remember, this is a new way of thinking, very different from algebra, so keep that in mind. And we really have to do a lot of visualizing in our own heads today to get through this lesson. All right. Do now. Identify each figure as two-dimensional or three-dimensional. Well, three-dimensional will show depth, right? Two-dimensional will be flat. So your only two-dimensional figure is the one in the middle. And then you have depth on the image on the left that looks like a ramp, and the box on the right, so those are three-dimensional. All right, you got some vocabulary terms you got to fill in. A polygon, okay. It's a long one. It's a two-dimensional figure with three or more sides. Not only is it a two-dimensional figure with three or more sides, but each side meets exactly at their endpoints. Okay? This part is very important. Okay? So a polygon is formed by two or three more straight sides. Well, if you check the definition above, we just wrote down that it is three. A circle is or is not a polygon? Well, if you think about that, a circle is not a polygon. The reason being is a circle doesn't have any sides. For a polygon, you need three or more sides. If you take a look at the polygon on the right, how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 sides. And all of the sides meet exactly at their endpoints. A triangle or a rectangle is a polygon with three sides. Well, tri means three, right? So triangles have three sides. Rectangles have four sides. The sides of a polygon are curved or straight. Well, again, if you take a look at our image here, we have nice straight sides. Two or three sides of a polygon meet at the same point. That would be two, correct? We have side one, side two, and they meet here. Again, you have side one and side two, and they meet here. Okay, so two sides meet at the same point. Cross out the figures that are not polygons. Well, the first figure doesn't even close, so that's not a polygon. The second figure, now we have this intersection point here where multiple sides meet together. That's no good because they're not meeting at their endpoint. They're crossing in the middle. So that is no good. Let me see if I can explain that a little better. You have this side, MP, and you have another side, QN. Their endpoints are where the dots are, or our segments, right? But the red and the blue line don't meet at their endpoint. They overlap each other, okay? So that is not a polygon. Your last figure is the only good one, okay? All of the sides meet at their endpoints. It's got three or more sides. So that's the definition of a polygon. You have another term today that we're going to need to know. Net is a two-dimensional diagram that can be folded into a three-dimensional figure. Two-dimensional diagram that can be folded into a three-dimensional figure. So it says circle the net that you cannot fold into a cube. Circle the net that you cannot fold into a cube. Okay. If I took our first image and I fold these three flaps down and I fold these around the back, that would make a perfect cube. That one's okay. If I took this one and fold these two flaps down and wrap 1, 2, 3 around the side, okay, that would be a cube. That's good. However, this one cannot be folded into a cube in the middle. All right, so it says, suppose you fold the net into a cube, what color will be opposite of each face? Well, you would have to fold your purple down and your red down, and then fold your yellow into your green and your blue and your orange around. So if that is the case, red is going to be opposite orange. Blue is going to be opposite yellow. And green is going to be opposite purple. So suppose you fold the net into a cube, what color is missing from each view? All right, well, if you fold the red down and the yellow over, you would have a green face in the front. Okay. If you fold it into a cube and you look at it from the angle of the blue and the purple, on the right-hand side, would be your green again. Oh, excuse me, that would be orange. Orange, sorry about that. And if you fold again and you look at it from the angle of the orange with the green on the side, then you would have blue on the top. Right, they're looking at these three right here. Identifying a solid from a net. The net at the right folds into a cube shown beside it. Okay, so we're taking this figure here and we folded it into a cube. A, C, E, and F all share an edge with D when you fold the net. A, C, E, and F. A, C, E, and F. A wraps around and joins with D to become the back of the cube, B becomes the left side, F folds back to become the bottom. E folds down to become the top of the cube, and C becomes the front. So what they're really doing here is showing you how this two-dimensional figure is folding into a three-dimensional shape. Okay, the net in problem 1 folds into the cube shown at the right. So they're showing B in the front. Which letter will be on the top and right side of the cube? So remember, you're looking at the perspective of B. What would be to the right? Well, that would be C. What would be on top? That would be E. Okay. Identifying a solid from a net continued. The net at the right folds into the cube shown. Which letters will be on the top and right side of the cube? So again, just take a look. If you fold B over, you would have C on the side and E on the top. Cross out the letter of the side that will not touch some side of face B. Well, you know A and B share a side. B and C share a side. When you fold B around, B and F will share this side, and E and B will share this side. So you would have E, A, C, and F. The only one that it does not come into contact with is D. So cross out D. Which side of the cube will that letter be on? And if it doesn't touch B, that must mean it's on the back side. Use the net. Which face is to the right of B? And how do we know? Well, we said C is to the right. Which face is on the top of the cube? Again, we already know this one, E. Drawing a net from a solid. So what is a net for the figure at the right? Label the net with its dimensions. Write T for true and F for false. 3 of the faces are rectangles. Well, I see a rectangle right here. Okay. I see a rectangle on this side. And I also see a smaller rectangle as the base. So that is true. There are 3 rectangles. 4 of the faces are triangles. That is untrue. I see a triangle here, and then I also see a triangle on the back side, which is here. So that's only 2. False. The figures have 5 faces in all. Well, I see 1, I see 2 in the back, I see 3 on the bottom, and I see 4 on the side, and 5 in the front. So if this unfolds, you will have 5 faces. That is true. First face is the rectangle. Second face is the rectangle. Third face is the rectangle. And then we just said the fourth and fifth are the 2 triangles on the sides. So write a description of the net. Okay. The net we don't know yet, so we can come back and fill this out. It says circle the net that represents the figure above. So the same figure, the top corner. Okay. And if you kept this base in the middle, this rectangle here is your bottom base. If I was to unfold this shape, you would have your longer rectangles on the side, which are these. And then your triangles would unfold out to the side. So here's your net. Okay, so it says, is there another possible net for the figure at the top? Well, you don't have to start with the smaller rectangle at the base. So what I'm going to do is I'm going to unfold from this rectangle here. Okay, your 10 centimeter rectangle. So draw a 10 centimeter rectangle, label it with 10s, and your sides are with 7, all right? And then what I'm going to do is I'm going to take this rectangle, let me see if I can change the color, and fold it over the top. So you have another 10 by 7 rectangle, which means that the base, or the bottom, would be folded the other way. But this is a smaller 7 by 4 rectangle. And the last thing you have to worry about is your triangles, the one in the front and the one in the back. I know this is tough to see. And they would come out this way. Okay, and the sides of these are 10 by 7. Okay, so here's another possible net. Very abstract thinking, I know. Number 3, isometric drawing. What is an isometric drawing of this cube structure? So, if you notice, the cube has how many edges that you can see and how many vertices that you can see. Well, edges I see 12, right? Well, actually, we can keep going. 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 23. And how many vertices do we see, which is corners? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you notice, they gave us one side already, right here. 1, 2, 3, 4. And that would be this side given right here. Okay. Notice the side length is 4. This is a cube, so every side length is going to be 4. Okay.
Yeah, I got my post approval back.
Oh, nice. Here's your 4s. Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And there's your first cube. I'm going to continue to do the second cube. 1, 2, 3, 4. 1, 2, 3, 4. Oops. 1, 2, 3, 4. 1, 2, 3, 4. There's the face. There's the top. Here's your other side. And there's your shape. All right, so here's an isometric drawing of a cube structure. We're going to continue to practice isometric drawings, all right? Nice visual, semi-easy to do. All right, give a shot with your exit slip. It says tell whether each drawing is isometric, a net, or neither. Does the drawing at the right show the surfaces of a three-dimensional figure as one folded out flat surface? Does the drawing at the right show the surface of a three-dimensional figure as one folded out flat surface? Well, if I took this shape and folded it back up, it would make a 3D figure, so the answer is yes here. Is the drawing isometric, a net, or neither? Well, what did we call those when we unfolded something earlier in the day? Circle the net, right? And what was the definition of a net? Right here. A two-dimensional diagram that can be folded into a three-dimensional figure. So, yeah, this is a net. Does the drawing at the right show the top, front, and sides of a three-dimensional figure using slanted lines to show depth? And the answer is yes. That's exactly what we just did, and we call those isometric drawings. Okay, guys. I'm not sure what happened to my exit slip sign here. There we go. All right, so thanks for watching. I know this unit is going to be a little different from the types of math that we learned in the past. All right, new way of thinking about math, and hopefully that's a good thing for some of us. All right.